For probabilities, we only have a few. And remember, if I give you something to count, you basically don't use the formulas, really. That last problem on the practice quiz, that one you definitely want to use the formulas because it didn't give you anything to count. It just gave you values for all the probabilities. But still, or is basically what? Add. I like it. This is going to come up again and again in the course. So I'm going to put and right here too. And is basically what? Multiply. I like it. Now just to remind you guys, if I'm you, probably look these formulas up in the book and double check. To make sure Jeff's bad handwriting plus my sitting in the back row maybe or something doesn't equal a formula that's not true anywhere. Right? So then we have probability of A given B, which is really where this formula comes from. Just divide by that and get probability of A and B divided by probability of B. So the real idea there is whatever is given becomes the new denominator. Because that's my whole world, and I know that thing happens. So it can only be any of those things. Oh, anything else? Off the top of my head, I don't think of anything else. Those are it. Oh, there's no formula for that. Ah. Independence is an idea.
Oh.
Right?
Well, fine.
You will not go softly into that night. No, sorry. Just go to Independence Day. Yeah. Well, fine then, yeah. This is a formula sheet, not an idea sheet, sorry. So you have to know the test for independence. So we can talk about that here in a minute, but
Mutually exclusive, the same thing.
mutually exclusive is also an idea. Yeah, there's no formula really associated with that. Okay, cool. Anything else you want to suggest that can go on here? Okay. Has everybody got? So that's nice. It's 1 through. I like it. Okay. So if you have that practice quiz, I don't know if you've tried it out yet. I mean, primarily the main thing you should be doing is your homework. It's the best thing you do for yourself. But practice quiz is a good way to see how I'm going to kind of word things and put them together. You know I'm going to have a table problem, like the Toyota Ford male-female one down there.
I won tickets.
You what?
I won tickets. It's like a probability. I was like doing the math. That's why I entered a concert ticket thing.
Oh, okay.
See, I put my number, and then I put my mom's number, and then I put my friend's number, and then probability of like,
You increase the chances.
Yeah, there you
Okay,
go.
cool. Thank you. Anything? Let me think. What was I just saying? So there's going to be definitely that table kind of problem, the contingency table. Basically, there's going to be problems just like what I've got laid out here, to be honest. I can't really change it up that much, right? Is there any specific questions from that practice quiz or from the homework for that section, for that chapter? Yes?
For number 4C, I kind of confused like what's the smallest.
Oh yeah, that's the hardest question on here. I love it. And so think about this. If so, the formula sheet is done, right? So everything in purple is the formula sheet. If the probability of A is 0.7, and the probability of B is 0.6. Probably A and B cannot be 0. Just can't be. Because if the probability of A and B equals 0, what's the probability of A or B? How do you do the probability of A or B? So this is a situation where I just gave you numbers. I didn't give you anything to count. So you have to use the formulas. So it'll be probability of A plus probability of B minus the intersection, which I just said, assuming it's 0, what does that lead to? So what's the probability of A? 0.7. It's probably B. 0.6. Yeah, minus 0, so 1.3. Now, if you get an answer like 1.3 and you circle it and you move on, I become concerned about you. Right? If something is definitely going to happen, that is a probability of what? 100%. What the hell would anything more than that mean? The highest any probability can be is 100%. Right? And I put that problem on the quiz specifically because you could say, how the hell would I know to look at that? Well, not until I put the problem on the quiz and we talk about it. That's why I put it on this thing, which doesn't count for anything. It's just a practice thing. So I want to subtract something to make this legal. What is the smallest amount that I could subtract to make this come out legal? 0.3. So what's the smallest probability of A and B could be in this case? 0.3. So I'm saying, if it was 0, this is the problem we run into. So what's the smallest this could actually be to make this problem go away? 0.3. That's the smallest number I can think of to subtract to make the answer come out to something legal. Now, if it was 0.4, it's still good. This comes out to be 90% chance, which is perfectly legal. Do you guys get the idea? And don't sit there and go, there's no way I could have done that. That's part of the reason why I put it here, so I could have this discussion about how to look at these things, right?
So would you solve it for 0 and then know what that number should be? Like 0.3? Like,
Yeah, so you could set it up.
yeah.
Might as well have A and B. And you say, okay, that's 0.7, 0.6, minus, I don't know yet. This is 1.3 minus, well, that's too big.
So the smallest has to be.
And you got to just figure out what would have to go there. So I'm not asking you to calculate what the probability of A and B is. I didn't give you enough information for that. I'm just saying, what's the smallest it could possibly be? Can't be any, what's the, 0.3. Can't be any smaller than that, because that would make the answer still illegal. Yes?
Where it says 0.7 plus 0.6 minus 0.3,
0.3.
when it said minus 0, where did you get the 0?
That was assuming it was 0
Oh, okay.
and seeing what kind of a problem I run into.
But if it were to say, like, if it said instead of 0, like 2 or something, then you would put, like, minus 2.
Of course. But of course, that was me just making something up, investigating it. So if I ask you, what's the smallest this could be? And you go, well, let's try 0. What's the smallest that any probability can be? What do I run into? I run into a problem. So that can't be the answer. It's got to be bigger than 0. And what's the smallest it could be to make this number become something from 0 to 1? 0.3. So could it be 0.7? Of course. Right? Because then this becomes 0.6, which is completely legal. Right? But what's the smallest it could be? 0.3. I like it. You guys don't like it. I don't care. This kind of problem, the reason I don't care, just to let you know, that so you don't go crying to somebody saying, my stats doesn't give a shit about me. I don't care because you didn't know before you even saw this how to think about it. That's why I put it there, just to see if somebody could think about this, a way to think about it, right? And if you didn't, it doesn't mean anything about you. It doesn't mean you're crazy or silly or whatever. It just means it's a weird problem to think about. Now, here's the way you kind of think about it, right? That's where, this formula is where A, B, and A and B interact. So this is where I could see where there might be a problem with the value of this. If it's too small, it's not going to be legal, the answer. Okay, so let go of that problem a little bit. I'm not going to give you a problem like that out of left field on the actual quiz. I just wanted that as a talking point for right now. Anything else from that practice quiz or the homework? It's wide open. Yeah.
I'm confused about the mutually exclusive. I remember the example, but not too well, so I was kind of stuck on this.
So if two things are mutually exclusive, they mutually exclude each other. One thing, something in A cannot also be in B. So if A and B are mutually exclusive, and it's weird trying to come up with examples, like we talked about cat, dog, put like rock and ice cream, or planet and eyeball, or whatever, right? If you are one of these, you cannot also be one of these at the same time. That's the point, right? That's what mutually exclusive means. So if I said, softball player and woman, is that mutually exclusive? Of course it's not mutually. If you're a woman, you could also be a softball player, right? Okay then. So that's the way you figure it out. You say if somebody is one of these, can they also be the other thing? If not, they're mutually exclusive. Now what does that mean mathematically if these two are mutually exclusive? What does it mean mathematically?
Equals 0.
What equals 0?
Probability
Well, what equals 0? Is that A don't equal 0?
A.
Probability of A and B would equal 0. Yes?
So on like 4B, it asks if they could be mutually exclusive and Y. Your Y part would just be your work, right? Or would you also want us to write out something?
So let me ask you this. On that problem, I tell you the probability of A given B.
Or like also when you ask if they're independent events, do you want us to write?
The work has to be shown, yeah.
Okay.
Yeah,
so
you can't talk the independence out. You
Do
have
we
to show
also
them
need explanation in words or no?
No.
Okay.
What's the formula for this?
Probability of B.
Okay, cool. So if the probability of A given B equals 0.2, could A and B be mutually exclusive?
No.
If they are mutually exclusive, then the probability of A given B should be 0. If it isn't 0, then no, they cannot be mutually exclusive. They have to have some overlap. This can't be 0. Right? If this was 0, there's no way in hell I'm going to divide 0 by something and make it come out to be 0.2. Can't do that. I love you guys. Thinking over it. But that's it. The fact that if they are mutually exclusive, this would be 0. So any formula that shows up, it would be 0 there. But I told you, like on that example, I tell you that probably of A, what did I say? It's A given B is 0.85. They can't be mutually exclusive because that's not 0. That probability is not 0. Do you guys see that? This is just number sense. Can this be 0 if I divide it by something and I get 0.85? No. If it was 0, I divide it by I don't care, I'm going to get 0. Okay, I can't do much more than that. 0 divided by anything is 0. If I get something that's not 0, then this cannot be 0. Right? Okay. Yes?
And number 2, part 1.
Number 2, where?
Part
Oh, part 1? Okay. So the probability of Twix, and then Snickers. That one? Okay. So I tell you that there are 7 Twix, 5 Snickers, and 1 Butterfinger. And then I ask you, now this first one is with replacement. What's the probability I get a Twix, and then a Snickers, right? Okay, so what's the probability that the first one is a Twix?
7 out of 13.
Yes, 7 out of 13. Then you drop it back in. You're looking for that Butterfinger, guys. You reach in and you get another Twix. So what's probably that happening? Still 7 out of 13 because you put the first one back in and you drop that in again. Where's that damn Butterfinger? Then you pull out one and it's a Snickers. What's probably that happens?
5 out of 13.
513. Come on. And then you just multiply that all together. Right? Just dump the bag out. Just stop freaking reaching in. Yes?
So in part 2 of B, so it's without replacement, so you get a Butterfinger and B0 out of 12, so that would just equal the probability of 0? Or?
Exactly. There's no way in hell. So if I'm doing this without replacement, there's no way in hell I'm going to get more than one Butterfinger. So any question about getting 2 Butterfingers or more is going to be a probability of 0. If I do it without replacement, I get that Butterfinger and I eat it. Yum, yum, I want another one. Too damn bad. You got a 0 chance of that. So what's the chance to get a Butterfinger and then a Butterfinger and then who cares? 0. You already took it and ate it. Right? The bag doesn't reset. That'd be great. Yeah. It's too bad. It's the weirdest thing from Dungeons and Dragons, the resetting Butterfinger bag. I mean, here, of course, you would multiply it outright. Get a little decimal, whatever. Yeah.
3D.
Real quick, before if part B is without replacement, so what would this TTS look like now? If I do it without replacement, probably the first one is a Twix. 7 out of 13, and then I eat it. So now there's one less Twix and one less candy bar. I eat it. And yeah, there's still all 5 Snickers. I haven't taken any Snickers yet, so there's still all 5 Snickers, but there's only 11 candy bars left in there. Please don't make more of it than it is. That's all it is counting. If I put them back in, none of the numbers change. If I take them out as I go, they change by 1, right? When does the top change? Well, if I just took the same thing out before, there's going to be 1 less of it. There's really nothing more to it than that. And we talked about why it makes sense it's going to be multiplication here. Okay. Yes. Number 1. So this is one sort of like that the North Korea problem, I think, on the other side, yeah. So this one says 26% of Americans disliked. So the probability of disliking Barack Obama's, this is back, obviously, I haven't changed this little practice thing in a while because I got the freaking answer key. I'm not going to change it. Probably disliking the plan is 0.26. What's the probability of liking the plan?
0.74.
Yeah. Or at least not disliking it. Okay. So it says I take 3 Americans, and I want the probability that the first 2 dislike it, but, which is a key, which is actually the word and, the third one liked it. So I want the first 2 to dislike it, but the third one to like it. So this is really exactly like that Butterfinger Snickers problem we just did. It's just that I don't have a small sample now. What's my sample size going to be? Americans, right? Holy shit! And there's over 300 million of them. So, what in that case? So I want dislike and like. So I make myself a little hangman game. Why there's multiplications in the middle? Because it's and. How are you guys doing? I mean, this. Okay. Yes.
Wouldn't that make 1C the same answer? It says at least 1.
Nope.
Oh no.
Certainly wouldn't. How many ways is there to have at least one like the plan? The first one will like it, or the second one, or the third one, or the first 2, or the last 2, or all 3. Holy shit! Or the first one and the last one. Holy shit! So that's why that part C has the shortcut that we can do. Thank God. So it's probably the first one dislikes the plan. Yeah, 0.26. Second one dislikes it. 0.26. And the third one likes it. 0.74. Which you could write as 0.26 squared times 0.74. Why does that make sense? Because I got 2 that don't like it and 1 that does. It's really beautiful. The exponents relate to how many of those you have. It's crazy. And I just got to throw that in the old calculator. So part B is pretty straightforward, right? Once you see this, part B is just going to be DDD. You want all three to not like the plan. Now look at part C. Let me show you. Let me try to show you directly what's going on. Probably at least one likes it. All right, if you try to calculate this directly, you can either do the probability of LDD. Is that at least one likes it? Yes, right? That's one likes it, so it's at least one likes it. Or, what does or mean? What does or mean in it? Yeah, it means add, right? Or basically means. Or I could do the middle dude likes it. Or I could do the last dudette likes it. I don't know what gender these people are. Or freaking the first two like it. That's still at least one likes it, right? What's at least one mean? 1, 2, or in this case 3. That's the most it could be. Only got 3 people. Or the last two like it. Or the first one and the last one likes it. Or they all freaking like it. So you calculate this and 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 add them all up. This is almost everything. What's the only thing I left out? All this liking it. So do you see how if I take all this, now please go with me. If I took all this and I added DDD to it, it's got to equal what? 1. That's everything. If I add DDD to all this, I get 1. So if I take 1 minus DDD, it equals all this shit. That's why that's the shortcut. The one thing I left out, if I do 1 minus that, it equals everything else. That's why that's the shortcut. At least 1 is the opposite of none. So at least 1 liking it is 1 minus probably of nobody liking it. And the beautiful thing is, I just asked you to do this in part B. I do that kind of thing all the time. I'm crazy. Like, yes, Jeff, you are crazy. We know this. Okay. Let me go ahead and give you guys the answer key here. And just to remind you guys, don't do this. That's bad. We talked about that before. Oh, you could put a percentage. Oh, yeah.
Okay, that's fine if you don't round. Like,
I'm going to tell you how far and around
okay.
on the actual quiz here.
Alright.
Yeah. Oh. Oh. Somebody's not there. Bless you.
wasn't here last class, so do you have like?
No, I just said a second ago. You didn't bring the extra copies with. Yep.
Alright, my bad.
Yeah.
What was given? What did that mean?
So if you're given more information, then that decreases the number of people it could be, the number of things it could be, right? So,
Living 3D.
yeah. Given that they own a Toyota, so how many people am I talking about?
People in Toyota.
Yeah, so how many?
Oh, okay.
269, right? And out of those people, I want somebody who's male, so how many chances to get a male? 114. Well, the reason I put the decimals the way I did is we're going to start doing decimals out to 4 places. There's a chart we're going to use later this semester where all the probabilities on it are 4 decimal place. So I just want to get you used to that. So on the quiz, I'm going to tell you, take the decimals out to 4 places, which means the percentages will be out to 2 places. Because you change it to a decimal and move it over twice, change the percentage. Bless you. I just want to remind you guys, I don't know if I come off as very unapproachable, but you know I have office hours. Somebody actually used them earlier. It was great. You can come by and talk about corrections, make sure you got them right. You can come by and double check on notes. You could say, I don't remember you talking about this. You could say, I don't have a clue what the hell this was about. I mean, then you got more of my attention. Because instead of 1 on 55, it's 1 on 1 or 1 on 2, depending on how many people are in my office. Really good idea to do that. So if my office hours do not work for you, just email me some other options. I am in my office more often than my office hours because I have work to do. But if I don't have a lot of work and you say you can come right by before whatever, and I will say, yeah, I'll be there. Just come on, knock on the door. Not a big deal. I mean, that's my whole purpose for being here, is to help you understand this stuff. And if you think you're going to get everything just by sitting in the classroom and doing stuff on your own, you are a little crazy. You need to use whatever resources are there. I'm one of them. The tutors are another one, right? And you got insane resources nowadays. My God. Anybody know about like Khan Academy, for example? Anybody ever heard of that? All right. If you don't like Khan Academy, some people do that and they're like, this guy's annoying. Go to YouTube and type in standard deviation and just start clicking on a few videos. There's a lot of crap, but there's some really good ones out there. Find somebody that you like, that makes sense. You know, it's amazing. I didn't have that stuff. Here comes the old, had to walk uphill both ways to school, but I mean, back in my day, we didn't have no YouTubes to look at. We didn't even have freaking graphic calculators for a while, hello. Or internets until the 90s, hello. So I don't know how you guys would survive if you went back in time, to be honest. But now you've got insane amounts of help. You go to Barnes & Noble. You guys know Barnes & Noble? They got study guides. And you know, you don't even have to buy the damn book. You could just sit down and work with it, right? Maybe don't rip shit out. That's bad. Don't be a bad person. I don't want to send bad people out into the world. Do you understand? I mean, I understand student budget. And living on ramen noodles and cheesy puffs, I did that, and this is not a joke. That was my dinner for quite a while. Ramen noodles are very cheap, so hey. So at least there you can just use it and put it back, and you're good, right? So do those things. man, come talk to me. It's free. If you get me through Craigslist, I charge like $40 an hour or something crazy. Yeah. All right. So any other questions from probability stuff? Gucci? What?
I told them.
Did you say
Thank you.
Gucci? What?
I thought that's what he said too.
Gucci? Is that what you said?
That we good?
Oh,
you
good.
said good chief?
Good chief?
Oh, no, I'm learning from
It's
my
like
cousin.
slang.
He said we're Gucci, like we're good.
Oh, is that what that means?
I don't know.
Is that a thing now?
I'm not fly like that. I can't-
You kids
I'm not
nowadays.
fly like
I'm just trying to bring gnarly back. Yes.
that. Wicked.
Say again? Yes, homework. 3-3. Number. All right, guys, I got a question from, it's page 212 in my book, but it's number 97 in chapter 3. Let's see. United Blood Services does stuff. Let's see. According to their website, a person with type O blood and a negative RH factor can donate blood to any person with any blood type. So those people are sought out. Their data shows that 43% of people have type O blood. So what can I write down mathematically related to that? What kind of symbols can I use? 43% of people have type O blood. 43%. Probability of O is 0.43. So a big part of this, the very first problem in this section was just translating from English into symbols. Right, the thing about the hair, I think I can remember how to use S, M, L, and F. If you've done the chapter 3 homework, this should be very familiar. So you need to be able to take what they tell you in the paragraph and the write-up and translate it into symbols so you can use it in the right place. 15% of people have RH negative factors. So probably if RH negative is 15%. Or just use an R, it doesn't really matter. 52% of people have type O or RH negative. So the probability of O or RH negative is 0.52. So this sounds a lot like that North Korea and Brussels sprout problem. Right? If you weren't here yesterday, like the Brussels, is that what we have in trouble with North Korea now? They're firing Brussels sprouts over Japan. Find the probability that a person has both type O and the RH. So we've written down in symbols all the information they gave us. What is in symbols the question they're asking us? Well, it's just going to be the probability that a person has both type O and the RH negative. Yeah, so it'll be O and RH negative. Now, there's a direct formula for this that requires you to know the given. Do I know any givens? No. So here's the next step. I've written all the stuff they gave me. I've written in symbols what the question is. Now, is there a formula that relates what I know and what I don't know? There is. Right? What's the formula for OR?
Probability of
Yeah, probability of O,
probability
probability of RH negative,
Minus
minus,
probability
oop, not A, O
O
and
R.
RH negative. So do you see how you know this? You know this, you know this, you don't know this. So that's like very, very light algebra required here, right? You just plug in what you know and solve for the thing you don't. But hopefully you guys see how if you try to use a formula for and, you don't get anywhere. Because do you have the given that you need? It requires you to know the given. I don't know any givens. Shit, okay. Then let me try a formula for something they tell me. There, the formula for something they tell me includes what they ask me about. So now just plug what you know in. What's going to go here? 0.52. O is 0.43. RH is 0.15 minus the thing I don't know. Combine, subtract, get it all, solve for that thing you don't know. A little tiny bit of algebra. So little I barely call it algebra. Is that cool? Is that all right? That's how that kind of problem works. So if I give you a table, or I give you cards, or I give you a bag with poker chips, you can count everything. This only gave me numbers with an event. Oh shit, I'm going to have to use formulas. There's no other way to do this. I have to use the formula for this. Oh yeah. And part B just says was probably they don't have both. It's just the opposite of they do have both. Right? Is that cool? So that's number 97, section 3.3. Say again?
Who solved that problem? The drawing?
Yeah, I'm leaving something for you guys to do.
Oh, no, I'm saying
Yeah, then you try to get this by itself.
can't you just kind of substitute that whole thing like that?
You could put an X here, sure. Make it look even more like algebra. Yeah. Can't, no. It's just that when you subtract this, you're going to divide by a negative, right? 0.52 minus 0.58 is negative, but there's a negative here too. There you go. I like it. Okay, cool. I like it. You guys don't so much, but that's the one time I would say you should use the formulas is if they give you just values for certain probability. Nothing I can count. There's nothing I can't put over something. The number of, I don't know, the number of anything. Shit. So I have to use the formulas. I like it. And what was the other? 98? So 98's a lot like this one. I think it's almost exactly like this one. Yeah, except here they tell me the and then they ask me the or. So I'm going to know this, I'm not going to know this. But I want to give you two, just to show you it doesn't matter what the situation is. I just use the formula and plug in what I know in the right place. One was talking about blood, and the other one's talking about final exams. It don't matter. Probabilities work the same way. Some of you guys are like, final exams, blood, they're related somehow. Anything else from homework stuff from chapter 3 before I get into brand new stuff? No? Okay. Okay. We are going to get into chapter 4. Now, today's going to include a discussion about why a formula we're going to use, why it works. And often when I do the whole derivation, people later say, why did you do all that shit? Why didn't you just do it? Because I'm trying to explain why it works. All right, I've always got that happen. So there's going to be some very mathish stuff to start with. So, chapter 4 is kind of like continuing a conversation we had in the early going. So one way I can give you data is just to list it. 11, 17, 29, 34. So we were doing a bunch of lists of data, calculating mean and all that kind of business, standard deviation. So now we're saying, are there other ways to be given data? And sure there is. So for example, let's say I walk around and ask people, how many pets do you own? Or do you live with, I guess, maybe, for those of you who call them your what is it, furry kids or something?
For babies.
Fur babies, something like that? Okay. So I don't own this being. I cohabitate with this being out here. Okay, fine. How many of you guys have pets? Anybody have pets? How many of you guys have just one pet? Anybody? 2 pets? 3 pets? 4? 5? I like the look on your face. What are you thinking about?
I forgot.
Okay. All right, I'm with you. I was just trying to figure out what could it mean. 6? Huh? More than 7. How many?
My like farm animals are my pets. We don't.
Oh, I see.
them
So
for
you just have a
anything
bunch,
else.
and who knows, one day to the
Yeah,
next there might be more. Okay. I'm with you. So instead of me making all the way down, I'm just going to make make up a sample, right? So I could ask people. Maybe some people don't have any pets, and let's say now this symbol could actually mean 2 things at the same time. This symbol does mean probability of X, but we can also look at it as percentage of X. And let me try to make sure you understand the similarity. If 22% of the people in here like Brussels sprouts, what's the probability that I pick somebody who likes Brussels sprouts at random? 22%. See, so that's what I mean. The probability and percentage are very often the exact same thing, right? So let's say that it turns out that 10% of people have no pets in my sample. Let's go up to 3. Let's say that 40% have 1 pet, 20% have 2 pets, and let's do this. 30% have 2 pets, and 20% have 3 pets. You might be able to see why I changed it. Just don't want the numbers to get 2 and 0.2 and 3 and 0.3. Now, one way this could be is I could have talked, if I talked to 10 people, how many had no pets? If I talked to 10 people, how many had no pets? 1. Right? Because what is 0.1? 1/10. 1 out of 10. So that I could, if I talked to 10 people, this could be 0. And 1 0. How many 1s? 4. How many 2s? 3. How many 3s? 2. Now, hopefully you understand that might not be the situation. I could have talked to 100 people. If I talked to 100 people, how many would have had no pets? 10, and blah, 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 so forth, right? So this could represent, it's just percentages, so I have no idea how many people I actually talked to. So this is a whole other way to give me data. I actually have no idea what the total number is, but I know what the percentages are. I just want to show you the connection between this is how we would have found the mean before, and how would we find the mean now. So this is the part that you'll never do again. You're just going to see why the math works the way it does. So what would you do here to find the mean? Add them up. So I'd have, let's do it like this. I have 1 0 plus 4 1s plus 3 2s plus 2 3s divided by 10. Now that is 4, 10, 15 divided by 10 is 1.5. Right? Let me just put over here. Equals 1.5. Okay. Right? That's what we would have done before. And I'm going to explain to you why we just don't do the same thing every time. I'll show you why you don't want to do that. Now watch this. Mathematically, I could split these up. So this would be 1/10 times 0. You guys see that? Plus 4/10 times 1. Yes, sir.
16.
16? Oh, I love it when I do that. So that's 1.6, right? 6, 6. Oh, I see what I did. Neat, Jeff. 16, okay. So that's 1/10 times 0. 4/10 times 1. 3/10 times 2. And then 2/10 times 3. I like it. And please, dear God, if I make a mistake, I am not the kind of person that's going to be like, I don't make this. I make freaking mistakes. I'm human. So let me know when I do that. Is everybody, now please, dear God, understand, I love the look on some of your faces. You're all like, why the shit would I do that, Jeff? We already got the answer. What the hell is your problem, dude? Well, I gave you a very simple problem just to investigate the math to see why it works the way it does. And then I'm going to immediately give you a problem where there's no way in freaking hell you want to do this. So we'll see if you see why in a minute. I'm just exploring the math. Another way to kind of calculate the mean. So here I still get 1/10 plus 4/10 plus 6/10 plus 6/10 is still 16/10. It's still 1.6. I mean, that's not amazing. It's the same stupid numbers, right? But now we have a whole different way to calculate the average. What's this? 1/10 times 0. That's 1/10 times 0 plus 4/10 times 1. So it looks like the way I could do this is to make a column. What would I call this column? What am I doing to get these elements and multiplying these two things? So what would I put up here? Yeah, x times p of x, right? X p of x. So this would be 0, 0.4, 0.6, 0.6, and sure enough, when I add those together, I get 1.6. So really, this was just me explaining why doing this will get me the mean every time. So let me show you an example of a problem. Let me see, for your notes, you're going to want to leave some space here. We're going to do some more, because if I need to calculate the mean, what's the other thing I need to go with it? What two things do I always want to get? The mean and the standard deviation. I want to know where the middle is and how spread out from that middle it gets on average. So that's the next level of this we're going to do, is how do I calculate the standard deviation if it's given to me like this? So leave some room over here. I want to give you you don't even have to write this down. We might do something like this here or later, but just to give you an example of why you wouldn't want to just write a list of numbers out that goes along with this. What would this mean here? If I did this here. I don't trust myself too much today. Let's see, so 8, 2, 6, so I think it's 1, 7, 4. What am I trying to make sure, of course? Adds up to 1. But I mean, how long would your list have to be? How many zeros would you have? 112. So I have to assume that we have 1,000 people. So you'd have to write 112 zeros. No, screw that. I want the shortcut way that we just developed, right? I did it specifically with a way that I could write a list so I could look at it both ways. From what we're used to into what we're going to do now. I like it. So how would you calculate the mean? You would just do x times p of x and then add them all up and you know the mean. Beautiful. I love it. Stop there for a minute. Yes, ma'am.
Can you repeat that?
Yes. Let me try this way. So is everybody cool with the fact this is the thousandths place, right? So if I had 1,000 people I talked to, how many zeros would I have? How many people would have said they had no pets? 112, right? You with me? So there'd be 112 zeros plus 509 ones plus ... over 1,000. Is that cool? That's the way I could do it. But why would I do that now that I know I can look at it like 112 over 1,000 times 0? Well, that's just this times this. Bam. And then this times this. Bam. And then this times this. Much quicker that way. So if they give it to me organized like this is just another way to give me data. But if the data is given to me like this, I want to develop a formula that works with that format quickly. Right? And that's what this does. I get the mean very quickly and when it's given to me like this. I'm going to let that sink in. Okay. The key here is to just realize if I did just give you a list of 1,000 numbers and there were 112 zeros and so forth, you would do exactly this math which relates directly to just multiplying these stupid things together and then adding them up. They are directly related. Okay, now, this is going to take a little bit of work. So maybe below this in your notes, you have your x, p of x. I want you to notice something. I multiply the value times what we sometimes call the weight. So for example, little side note here. In a class like mine, you've all taken classes where the grade is based on points. Do you know what I mean? Like the quizzes are each 30 points, and the midterm is 500 points, and all that kind of crap. Those are people that don't know math too well, to be honest. So if there's any math people doing that, it makes me a little bit sad. I'm not saying my way is better, I'm just saying it's more mathematical. So here, basically, like if tests were worth 50% and quizzes are worth 20%, and then the final, let's say, is worth 30%, just to simplify. Do you know how to calculate your average? Let's say you get a test average of 81, a quiz average of 92, but then the final exam, you forget to drink your coffee and you get up late and you have a flat tire and you get there and oh shit, and then you get a 71. Can you figure out what's your average? Yeah, you do like we just figured out. You take 0.5 times 81 plus 0.2 times 92 plus 0.3 times 71. And then if somebody can help me out, whatever that is, that'll be what that comes out to be. Let's see. 40.5, 18.4, 58, 59, 2, 21.3, I think it's 80.5. 80.2? All right, for today, that's pretty good. 80.2. I like it. Okay, all right. You guys kind of with me here a little bit? Do you see how that is exactly